I'm Nick, we have Zach, Tyler, and Jerry, and we are the Dynamics project for Instantaneous Center of Velocity. What we did, we took a problem from the book, which was a wheel with two different velocities going out in opposite directions. So what we did, we took two boards, put it in between two rolls of paper, and made them go at different velocities. And that would raise instantaneous center of velocity based on the different speeds of it.
I'm Jerry, and I'm going to be describing the diagram. We have a wheel in between two boards, and the wheel is not slipping, so the velocity at A and the velocity at B are the velocities of the velocity of the boards measured by the photo gate sensors. Using similar triangles, the first equation, the velocity of B over the radius of B from the IC, the instantaneous center, is equal to the velocity at A over the diameter of the wheel minus the radius to B from the instantaneous center. From this, when we find velocity at A and velocity at B using the demo, we can find the radius BIC, and then with velocity at B, we can find omega, and from there, using omega, we can find the velocity at the center of the wheel.
Hi, I'm Zach, and I'm going to be explaining the actual demonstration of our project. What we have is we have two boards that have picket fences that will be reading with the photo gates and logging on Logger Pro, sensing the velocity of each of the boards that move. And then we have a motion sensor that senses how fast the actual cylinders or rolls of paper are moving when we move them.
1.9. Yeah, 1.9. Okay, my name is Tyler, and so now that we have done our experiment, we have the velocities that we need. We replaced our original values and have solved for the center of velocity of our cylinders. So we plugged in our VB and VA into our equations here that related the ICs and the two velocities, and we solved for RVIC, which is this distance here, and we use that to solve for our omega, which is the angular velocity of our system. And using omega, now that we've solved for that, we can solve for the velocity of our cylinder. And as you can see here, 0.07 is the same as our actual value that we got during our experiment. Thanks.